Well, hello and welcome to your first flipped lesson for this class. As you go through this lesson, I would strongly encourage you to take notes. Make sure you take really good notes on your own, notes that when you go to look at this later on, you understand what it is you were learning. But you are taking notes for you. You're not doing it for me. You're taking them for you to understand later on. I also know most of you know how to write the equation of a line. You've been doing it for several years now, but what I'm going to show you is a quicker, easier way to do this. And I really think when you see it and when you try it for yourself, you will love it. But let's talk about writing equations of a line. I mean, there are many different ways you can do it. There are many different forms of the equation of a line. Here are some that, just to name a couple, the more popular one. There's this form called standard form, and you may or may not have seen it. Standard form, as you can see by the picture I chose, very formal looking. It is standardized in that it always appears with something times x plus something times y. That's always on the left-hand side equals a constant. And the coefficients, a, b, and c, cannot be fractions. So standard form looks very nice. It's very pretty to look at. It's not super practical, but it's very pretty to look at. There's another form you may or may not have seen called intercepts form. Intercepts form reveal right away the x-intercept and the y-intercept. And we'll actually talk about intercepts form later on. I just want you to see it today. That's all. And then we have what seems to be everybody's favorite, slope-intercept form. Slope-intercept form I call the workhorse of all the linear equation forms that we have. You remember this from Algebra 1. It's y equals mx plus b. M in blue here represents the slope. Slope is the rise over the run, the rise over the run. And b in this equation represents the y-intercept. It's where the graph crosses the y-axis. You know slope-intercept form. You've been using it for years. You're probably excellent at it. But there is another form out there that most kids do not realize they already know. And it's called point-slope form. And this is what point-slope form looks like. Now, you may need to pause the video to write this down, and that's great. But point-slope form looks like a generic y, just like this in slope-intercept form. This is a generic y. Generic y minus y sub 1. Well, y sub 1 is simply just a point. It is the y value of a point. Equals the slope, m, times the quantity, generic x, just like over here, this is a generic x minus the x value of that same point. That's it. That's called point-slope form. And point-slope form, I think, is one of the secrets of math that shouldn't be a secret. All kids should know this. But let's dive in and let's talk a little bit more about what's going on here. So, which form should you use? Well, that all depends on what you want to do. If you want to graph a line, slope-intercept form is your go-to. You know, you have this b, this y-intercept. That's your starting value. You mark the y-intercept. And then m is the slope, and you use the slope, the rise over the run, to generate all the other points on that line that you need. Slope-intercept form, it's a great form for graphing a line. But what if you want to write the equation of a line? What should you do then? This is where I'm going to make the argument that yes, I know for years you've been doing it through slope-intercept form. It's not the quickest way. It's not the best way. Let me win you over to point-slope form. Point-slope form again. You know m is the slope. That's just like it is over here. But instead of being concerned about a very specific point, like the y-intercept, point-slope form is concerned with any point whatsoever. X sub 1, y sub 1 is just some point through which the line passes. It doesn't have to be the y-intercept. It's just some point. Well, I think the best thing to do is just to get in and do some problems. So let's take a look at our first problem. Why don't you in your notes take a second and write down what I want you to do here. So pause the video, write this down, and then come back. Okay, now I know everybody in the past has done a problem just like this. I mean, you could have even done this problem. But I'm going to show you how you can use this new form, point-slope form, to finish it in mere seconds. Watch this. So here we go. We're going to use point-slope form. And generically, you should remember that this is what it looks like. And over here, I have the structure or the bones of this equation written out. It's y minus something equals something times the quantity of x minus something. Now, it's y minus what? It's y minus this y value right up here. So this y value is a 5. So this 5 goes right there. Equals, what's this? Well, according to our generic form, it's the slope. Whoops, sorry about that. It's the slope, 3/4. And then it's x minus something. X minus what? X minus -2. That's our x value. There it is. That is the equation of the line. And other than this awkward minus a negative, which we can kind of clean up here, that's what it looks like. That is your equation. That was super fast. I don't care what the y-intercept is. I just need an equation that works. And if you put a -2 in for x and a 5 in for y, you will get a true statement. Isn't that awesome? Isn't that way quicker than slope-intercept form? Let's do another example. Here we go. Why don't you jot down what I want you to do here, pause the video, write it down, and then let's get started. Okay, hey, welcome back. Hopefully you pause the video and we'll get started. Now, what do we want to do to write an equation in point-slope form? Well, let me remind you what point-slope form is. It's this. And to write an equation in point-slope form, you simply need a point, and hey, we have two. We could use either point, it doesn't matter. But you also need the slope. And so let's find out what the slope is. Okay, so we know that we've got to find the slope, and the slope is the rise over the run. And you remember from your algebra days that you find the difference in your y values divided by the difference in your x values. So it doesn't matter which y is y sub 1 or y sub, it doesn't matter, just be consistent. So I took the second y minus the first, and when I say be consistent, I mean if I did -1 minus 5 in the top, I've got to do 1 minus -3 in the bottom. And this ends up being -6/4, but you know, it looks weird. Let's call it what it really is. It's really -3/2. So we just did all of that work and we found the slope. This is our slope. So now that we have the slope, we can go directly to point-slope form, and we can use this secret point-slope form to write the equation. Again, generically, that's the structure of the equation. We just have to plug in the slope, which we know is -3/2, and we have to plug in an x value. Which x value do you use? It doesn't matter. You could use -3, you could use 1. It doesn't matter. So let's use -3. So I'll put a -3 in there. Ooh, look what happened. +3. And if I use -3 for x, I have to use its partner y, 5 for y. And that's it. We're done. We're done. It's wonderful. Let's do another example. I just want to go through one more. We know what point-slope form is. Why do I love it so much? It's because it's so quick. So quick. So here's another example. Boom. Again, why don't you pause the video and see if you can do the entire thing by yourself. Go ahead and do that right now. Hey, welcome back. I hope you paused the video and you're not just making me look like an idiot when I yell, hey, welcome back, and you went nowhere. I hope you did this by yourself. Let me just go through a very quick setup of what you probably did. I'm assuming you first found the slope, and regardless of which way you did it, whether you started with 7 and subtracted -5, or you started with -5 and subtracted 7, your slope should have been -12/5. I hope for step 2 you were smart and you put it into point-slope form. I hope that you picked any point. It doesn't matter which one, 2, -5, or -3. It doesn't matter. But you put in those numbers, and you may have ended up with something like this. Or if you used -3, 7, you would have a y minus 7, and in parentheses you'd have x plus 3. But this takes me to something else. We're not quite done with this, because depending on which point you used, you could get two equations that look different, but they're the exact same. So I want to talk to you about how I want your answers. And I'm going to ask you to standardize your answers. So regardless of which point you used, I want everybody's answer to look the same. And that is going to be done through standard form. And this is just a great way for you to practice how you can manipulate equations to look a certain way. So when you're taking the AP Calc test and it's multiple choice, and the answer you got doesn't look like it's there, you can learn to manipulate it to see if it's one of the choices they gave you. So let's talk real quickly about the rules for standard form. Again, pause the video as you need to. First of all, there are no fractions. You cannot have fractions in standard form. And second of all, it's standardized. It has to look like something times x plus something times y equals something, and those somethings cannot be fractions. So let's take the equation up above, and let's see how you would solve this in standard form. So the first thing I might do if I was trying to do this in standard form is distribute. I mean, this tells me I have to take this -12/5. I have to distribute. Notice in standard form there aren't parentheses anywhere. So I did that. I went ahead, I took the -12/5 and I distributed it. And I ended up with this. Remember, a negative times a negative is a positive, and you know how to deal with fractions. Ooh, fractions. There can be no fractions. So my next step was, well, gosh, let's just wipe out the fractions. We can't have them anywhere. And this is where we rely on that old Algebra 1 trick of eliminating fractions by multiplying by the common denominator. And in this case, I think the common denominator we want to multiply each and every one of these terms by is 5. So to wipe out the fractions, I multiplied everything by 5, and that gave me this. 5y plus 25. And then when I distribute the 5, they cancel out here, and I get -12x. They cancel out here, and I get 24. The last thing we have to do is line it up in the right order. Remember, x's come first, followed by y's, and then on the right-hand side are the constants. So we have to move some things around here, and we end up moving this -12x over, and that is standard form. It doesn't matter. It does not matter which point you used up here. You're going to end up with the exact same standard form because it's standardized. Now, we're going to end this lesson with one last example. And the last example is I want you to try this on your own. Don't blow me off. Pause the video. Try it on your own, then come back and check to see if you did it right. So, here you go. Welcome back. I hope you paused the video. Please don't make me look like some type of fool while you're just watching the video, not doing any work, and I'm just blathering on. Try it. So first thing, find the slope. I hope you did that. I hope you found the slope. Where is it? Whoops. I hope you found, whoop. There it is. I hope you found the slope to end up being -1/2. So once you've got the slope as -1/2, now get an equation as quickly as you can. Again, you're not going to go directly to standard form. That's too hard. Just get an equation that works. I'm thinking you're going to want to maybe put in that slope and pick a point. It doesn't matter which one. Maybe you put 5 in for the x and -4 in for the y. Great. There's your equation. And now that you have an equation, you can manipulate it into standard form by doing the math. We take this equation. Remember, it's y plus 4 because 2 negatives make a positive. I'm assuming you're going to distribute. I'm assuming then that you multiplied both sides. Maybe I'll get my pen. Multiply both sides here by the common denominator, which in this case is a 2. And when you do that, the fractions are gone. And the last thing you do, once you wipe out those nasty fractions, is you standardize it. X's come first, Y's come second.